So now let's talk about how do we compare variation in our data when we have data that's collected from two different samples or we're trying to compare two different populations. Now, what we've been using before to compare variation in our data set was we used the standard deviation. Okay, and recall that the standard deviation measures the variability in our data relative to the mean. So if I have two different samples or two different populations, right, I might be looking at two completely different means that might even have different units of measure. So we do not want to use the standard deviation to compare how two different samples or two different populations vary because again, it depends on the mean, and those units could be different. So what can we use instead to still measure the variability in our data? And the answer to that is we're going to use something called the coefficient of variation, which is sometimes referred to as CV. So anytime you have a set of non-negative sample or population data, so again, we're looking at numerical data here, the coefficient of variation is expressed as a percent. And so we can describe the standard deviation relative to the mean in terms of a percent. And there's a formula for calculating that. So I'll give you the formula for when you're calculating the coefficient of variation for a sample, and then also what that formula would be if you were looking at population data. Okay, so the CV, right, you simply take your sample standard deviation and you divide it by your sample mean, and because we want to express it as a percent, once you have that ratio, you multiply it by 100, and that will give you the coefficient of variation as a percent. So for the population, you would take your population standard deviation, which is sigma, and you divide it by the population mean, which is mu, and again, multiply that ratio by 100 to get a percent. So we'll take a look at an example next. Okay, so in this example, we're looking at pulse rates, which is measured in beats per minute for a sample of males and a sample of females. So clearly we have two different samples that come from two different populations. And if we want to talk about which gender, right, has more variation in their pulse rate, so do males vary more in their pulse rates or do females vary more in their pulse rates, we would have to calculate a coefficient of variation. So to do this, we have to first calculate the mean pulse rate for each sample. So let's break it down first and calculate it for the male sample and then for the female sample. So what I would do is I would take out my graphing calculator and maybe put the male data into L1, so list 1, and put the female data into list 2. And once you have that in the list, you can do one var stats to get your sample statistics. So go ahead and take some time to do that, and then you can check with me here to see that the mean pulse rate for the male is approximately 69.47 beats per minute. And for the female, that mean pulse rate is 82.13 beats per minute. So already we can see that from this sample, on average, females have a higher pulse rate than males. And then if we take a look at the sample standard deviation for each sample, the male pulse rate varies by about 11.27 beats per minute. So that's how much a typical male pulse rate varies from a mean pulse rate of 69.47 beats per minute. And for females, that standard deviation is 9.21 beats per minute. So here, the female standard deviation is smaller, but that's relative to a mean that is higher. So here, we don't want to use the standard deviation to compare, okay? But what we can do is calculate the coefficient of variation. So for the male data here, that formula, remember, is just S divided by X bar times 100. So that would be 11.27 divided by 69.47 times 100, which gives us a coefficient variation of 16.2%. And then for females, that coefficient of variation is going to be 9.21 divided by 82.13, which is approximately 11.2%. So here, if we were to compare the coefficient of variation, we can see that males vary more in their pulse rates than females because that coefficient of variation, that percentage is higher.